Hello and Assalamualaikum to our panelists and viewer for my presentation. This video is in purpose to present about my final year project MEC601 with project title of Study of Wear and Friction on Implant Materials using Pin-on-Disc Testing. My name is Ameer bin Azmi and I will be the presenter of the video. My supervisor is Mohamad Mazwan bin Mahat. Please enjoy my video. Project summary. This project study on wear and friction of implant materials. It is conducted using NC software by sketching 3D geometry model of pin and disc model using arches wear and finite element analysis. Study on titanium alloy for total knee replacements biomaterial. So basically our implant materials we choose titanium alloy. The purpose of the study is to acquire the wear rates obtained to the titanium alloy, which act as cartilage material. The preliminary results from finite element method can be used to find the wear rates of the titanium alloy with different loads. The different loads is based on the different activity of human. Introduction. What is cartilage? Cartilage covers the end of bones of tibia and femur in knee joint, as we can see on this figure. The motion of knee in daily activities can cause wear to the cartilage, and it is known that cartilage has limited repair capability since it is a flexible fibrous tissue. Thus, knee surgery is required if the cartilage has worn out or damaged. The demand for cartilage replacement is increasing year by year. Based on simple search, the trend for knee replacement journal published keep increasing from 2011 to 2020. Literature review. Total knee replacement is one of the best methods to remove deformity. It is necessary if the medication method is no longer effective for your knee deformity. The selection of implant material is crucial in improving durability of knee joint, since there are choices of suitable material for implants. Tribology. Tribology measures tribological quantities between two contact surfaces. Pin on this tribometer used to observe wear during sliding. Basically, for our project, we use ANSYS software to simulate the pin on this rotation. So we can apply the material to the pin or to the disc to simulate our pin on disc. The material selection for total knee replacement must be biocompatible, which the material can function in the body without generate a problem to the body. In this market, there are a number of choices for biomaterial. However, implant material needs vary based on the patient's health, design, and surgical process. Titanium alloy is common material in total joint replacement. Good mechanical properties for material knee implant. Because of its outstanding qualities such as low Young's modulus, chemical stability, low thermal conductivity, and biocompatibility, titanium alloy is commonly utilized in total knee replacement. Besides titanium alloy, polymer and stainless steel are also the most widely used as biomaterial for total knee replacement. Problem statement. Forces acting on knee due to daily activities can worn out the knee cartilage. Titanium alloy can lead to wear due to constant force sustained constantly. Patients that facing knee injury and the medication treatment is not helpful, they need to perform total knee replacement surgery. The material for total knee replacement need to choose according to a suitable of mechanical properties for implant material on human joint. Based on the previous journal, the lack of the study and data on wear rates of titanium alloy as material implants bring to this proposal. The objective of this project proposal is to study structural parameters of biomaterial based on different loads, to study wear rates of the biomaterial used for total knee replacement. The scope and limitation of the project proposal is the result obtained based on structural parameters for wear rates using ANSYS software. The load 750 and 850 Newton is based on walking and jumping activities. The force is exerted based on the walking and jumping activities on human daily activities. Titanium alloy is used for the material for pin and disc. There are 6 steps for our project flowchart. The first one is literature search. About 50 journals were downloaded that related to topic for literature review. Next is problem statements. The wear occur in biomaterial implants and lubricant used to reduce wear. Parameters used: Young modulus, Poisson ratio, yield strength, shear factor. Next is geometry modeling. It is drawn using ANSYS software. Numerical analysis: analyze using ANSYS software, arches wear simulation. And for our results, maximum von Mises stress, total displacement, strain, volume loss due to wear, and wear thickness. Methodology: geometrical pin on this model. Figure below shows a three-dimensional pin on this model created with ANSYS software. The design of the pin represents the shape of femur. The design of the disc represents the shape of tibia. Next is mesh generation. The mesh was generated. To refine the mesh, edge sizing function was used in the contact area. It is a solid mesh with 590 total nodes and 1163 total elements. Methodology: geometrical pin on this model. Figure below shows a three-dimensional pin on this model created with ANSYS software. The design of the pin represents the shape of femur, while the design of the disc represents the shape of tibia. For mesh generation, the mesh was generated. To refine the mesh, edge sizing function was used in the contact area. It is a solid mesh with 5490 total nodes and 1163 elements. The 3D model of finite element mesh is generated as shown in figure below. Boundary condition for finite element analysis. The first one is Young modulus, which is 96 GPa. Next is Poisson ratio, 0.36. The shear modulus is 35.3 GPa, and the yield strength is 930 MPa. The wear rates of material. The formula is used is K equal to delta V over PL. K is the coefficient of wear, delta V is volume loss on material, P is load, and L is sliding distance. For this project, Archer's law is used to calculate the wear rates for the material. The formula is shown: W equal to K over HPV, where W is wear rate, K is coefficient of wear obtained from pin on this experiment. H is the hardness of softer material, P is the applied pressure or load, and V is the rotational speed of the disc. Preliminary result: von Mises stress for 750 Newton and 850 Newton represent the equivalent stress state of material before the distortional energy reached yielding point. The value must not exceed yield stress, which is 930 MPa. And this is the result for our von Mises stress based on different load. Preliminary result: there are two types of movement: walking 750 Newton and jumping 850 Newton. This is based on our research on journal. Maximum von Mises stress MPa 10.34 for walking, 10.35 for jumping. Maximum strain 1.0771 times 10 to the power of negative 4 and for walking, and for jumping 1.0782 times 10 to the power of negative 4. For total deformation, the unit is millimeter. For walking, 0.19112, and for jumping 0.19112. So it is the same total deformation, maybe because of the almost similar force. Volume loss, millimeter cube. For walking, 8.0074 times 10 to the power of negative 5, and it is the same for jumping, 850 Newton. Maximum wear thickness for walking and jumping is the same, 5.3802 times 10 to the power of negative 7. All of this result is based on our ANSYS simulation. Expected result: The goal of the strength of maximum force means stress based on two different knee deformation, based on various loads applied and predicted wear rates of material used. As shown in figure, we can expect the wear rates of the titanium alloys on dry condition via the Achat's law formula by using the volume loss due to wear and thickness. And for our conclusion, Achat's wear is used in ANSYS to determine the volume loss and wear thickness of the material. The project will be resumed to find the wear rates for different loads exerted. The result shows that more improvement to the design and analytical elements are necessary in the future. Thank you. That's all for my final year project proposal presentation. Thank you for listening. If you have any inquiries, do not hesitate to email me at ameerazmi21@gmail.com. Thank you. Bye bye.